We've travelled today to Hexagon Metrology, where we wanted to get a greater understanding of metrology within the aerospace sector. Now, many of us have travelled on a plane at some point in our lives, but we wanted to find out more about how critical the measurement of components is to our safety. So welcome to this week's Wharf and Chips. So we all know that an aircraft is generally made up from 6 key parts: the fuselage, cockpit, wings, tail, engine and the landing gear. We are talking about an average of 4 million individual parts plus on one aircraft. Now, every part on a plane needs to be measured, depending on its use and how critical it is, and sometimes this can be down to sub-microns. So how is all of this measured? Through metrology.
Metrology in engineering, in its simplest form, is the science of measurement. So for that is measuring parts to ensure that they're within specification, so that the supplier is producing and supplying parts that are correct and are going to work. But it can also be used to optimise your processes and efficiencies to maximise profits.
How important is metrology?
The whole world evolves around metrology. Everything we do from the moment we get up in the morning, metrology is measuring everything. When you make a cup of tea, do you put 1 sugar in there or 2 sugars? That's metrology, it's measurement. So metrology in aerospace, it's very much safety critical, 100% inspection. Every single part you need to know is correct, within specification, is going to work and not fail.
Tell me about the range of metrology on an aircraft.
The range is vast, everything from the seats in the aircraft being the right size and shape, to the seatbelt buckles being functional, working and safe, but then down to the sub-micron measurements required on your engine parts within the jet engines, such as the curved couplings. So we're looking at sub-micron measurement on all those safety critical parts.
Let's put a micron size into perspective. From a paperclip at 0.8 millimeters, down to a pin, down to a horsehair, down to newsprint, to a human hair, a phone protector, a spider web, and then what is not visible to the human eye, a micron. So on an aircraft, every part is critical, from the heaters heating up our beverages to the clips that are keeping the doors locked, all the way down to the bearing on the wheel that hits the ground on landing. So this means that many parts have to be made and measured to the strictest of tolerance. So I wanted to find out what machines do what exactly, which machines measure to the highest measurement, how they align the wings through measurement, and what are the most critical components that allow us to fly above the clouds.
Aircraft are designed and manufactured generally all over the globe. They're measured at the local point of manufacture, and then also measured at the point of when they actually arrive at the OEM for installation into the central aircraft itself. Here at Hexagon, we use various measurement instruments, i.e. trackers, portable arms, or CMMs, to measure various components, and we support the installation of aircraft at many levels.
But how do you decide what measures what?
A number of inputs. So the first thing is the size of the component that we're looking to measure. The second thing would be the tolerances that we need to achieve, i.e. is it sub-micron, is it microns in terms of 2, 3, 4, 5 micron in terms of accuracy. And then we'll choose the relevant equipment that will satisfy the job.
How are your products used in the certification process of an aircraft?
Many ways, really. That can be used from simple testing right the way through to structural testing of a full frame of an aircraft. One example of that would be is a strength test or a fatigue test of an airframe, where we would use a tracker product because it's a large volume and we need to actually encapsulate the whole volume and understand how that is deflecting under certain loads. Those kind of tests give us confidence that aircrafts are safe to fly.
quality in aviation is paramount. It's basically a requisite for all components that are manufactured that comprises of the plane itself. They enable them to show high tolerances and under stringent measures that they are produced under strict controls, and enables that to be of a high product and satisfaction to their customers.
What and why are we measuring in sub-micron measurements?
Okay. Obviously, the product range within the devices that we have here at Hexagon is a ultra high precision CMM, which has the capacity and capability of measuring sub-micron measurements. This is for tighter tolerance components and various artifacts that can be done that you found within the aviation industry.
But is that all down to traceability? Why do we need such tight tolerances?
Well, we need that to push the boundaries of quality. We need that to show a product that can withstand the rigours of everyday wear and tear, and also the fact that high quality product has obviously been constructed primarily to withstand all these stringent tests that they have to go through in order for safety purposes.
It's so interesting to find out that parts of planes are made from all over the world and they come together. But where do laser trackers come into the measurement of components then?
So laser trackers are involved when we need large volume metrology. We're not talking the typical CMM bed, which is about 3 to 4 meters. We're talking 40 meters plus.
Yeah.
So we have a 80 meter measurement volume on a laser tracker, which means we can measure the plane in one go. You know, so the full assembled aircraft could be measured from one station alone. So think of a wing, for example, where we have a left wing and we have a right wing. When we attach the wings to the side of the plane, we use the marry-up facility and we level it in and we align it to the fuselage so we can get this perfectly parallel, because what the engineers are looking for in the small dimensions is to generate the lift and the thrust and to minimize the drag through the air. So when we use the laser tracker, we can set that wing, we can set that at the perfect angle to generate as much lift as possible and make the aircraft more efficient. And then it's used to just simply attach the wing to the fuselage in the desired location and goes from there.
CMMs are very popular. So what is it that a CMM would be good for measuring on an aircraft?
Well, the CMM can measure virtually any part that you want to, but we're focusing on complex parts, speed, accuracy, automation. If we take a turbine blade, that could be robot loaded, put onto the machine, we measure it taken off, so we can have a fully automated process.
So how does this physically work and measure parts?
Well, this particular machine is using an analog scanning probe with a 2.5 degree incrementing head, which means we have over 12,000 positions that we can index to. And then we can scan parts extremely accurately, but also very quickly, and we can use a fully automated process.
But you have other varieties of CMMs and you can have different heads on the end, can't you? So explain that to me.
Yes, we can have what we call touch trigger sensors that take individual points, but the scanning head enables us to collect data much quicker and more accurately. But then we can also add laser scanners on there, which are stripe scanners, so we can collect even more data much faster. We can also fit cameras to look at things. So we have a whole suite of sensors to make us be able to measure anything we want to.
You mentioned speed and things to be quicker and faster. Why is time of the essence here?
Efficiency relates to profit. The faster we can measure something, the quicker we can supply things, the faster it can be fitted. It makes us more efficient, it makes us better, makes us more profitable.
So this absolute arm, we've got the RS6 scanner on it. It's a very powerful scanner. When used on the surfaces, it collects a lot of data, and that data is then used to compare the initial design to the final product. So with the flexibility of this absolute arm, it's able to collect all the data all around the part.
It's interesting to find out about the components and what machines they suit, but I wanted to find out more about what improvements customers have seen and found when using such high accuracy measuring tools.
Over the last 20 years since I've been involved with laser trackers, we originally started measuring 3 dimensions, and over the years the technology has changed to this current T-scan products, which allows us to scan surfaces. So customers that build aircraft, for an example, can measure their carbon wings, and they've found over a period of time that they can measure the wings so accurately they can reduce the thickness of the skins and make the planes more fuel efficient and obviously lighter and save money.
So what is the latest on the trends in aviation?
So some really exciting times, I think, going forward for aerospace. There are a number of new advancements in different materials, particularly composites going forward. The electrification of aircraft in terms of different engines, so are we going electric, are we going hydrogen cells, etc. So a lot of research and development going into that area. Some of the key things that OEMs and first tier and second tier providers into the OEMs are looking at is zero defect plans within manufacturing, and that is literally encapsulating what the traditional approach of finding defects is at the very end of a process in final view, final inspection. That is now being rolled back, so after each operation within the manufacturing cycle, the actual component is either measured or scanned to check for defects. So you're not getting to the very end of the process, you're actually capturing it at the very start and correcting the issue. So then flowing down from that, you should have a 100% compliant component.
Wow, certainly a huge education for me, and I hope yourselves too. And this isn't just what happens in aerospace, it goes across so many industries, and it's also a vital component of certification and traceability of all of those parts. So don't forget, next time when you're on holiday, you best be thinking about all of the measurements that have gone into all of those parts on that plane that got you to that sunny beach sipping your pina colada. Thanks for watching this week's Swarf and Chips. Don't forget to like, comment and subscribe. And as we always say, keep those spindles turning.